got a good selection of problems here. So we've got everything that we've covered so far. For the most part, we didn't do all the conversions today, but pretty much every problem type we've seen so far we've got in the opener. So starting with number 1, we want to convert 96% to a fraction. What does percent mean? Out of 100. So 96% means 96 out of 100. And how would we write 96 out of 100 as a fraction? 96 over 100. So 96% is the same thing as 96 over 100. And then once I convert anything to a fraction, I need to make sure I do what? Reduce or simplify, right? The only things we need to check are 2 or 5. Does 2 go into both of these?
Yes.
Yeah, so we can reduce by 2. That's going to give us what? What's 96 divided by 2? And what is 100 divided by 2? All right, can I reduce that? Yep, can reduce again by 2, right? So we reduce by 2 and we get 48 divided by 2? 24. And 50 divided by 2? 25. Can I reduce that? No. So I could reduce the 24 by 2, but I can't reduce the 25 by 2. I could reduce the 25 by 5, but not the 24. So that means we are done. Next one, we want to convert a decimal into a fraction. Sometimes when we start working with percents, a lot of people are tempted to just use 100 for everything. But I don't want to use 100 as my denominator here. Why not? What is my denominator going to be for this problem? It's going to be 1,000. Why is it 1,000? Because the last decimal place here is the thousandths place. So since that's in the thousandths place, we're going to have 1,000 in the denominator. What's going to go in the numerator? 125. Once I write the fraction, what do I need to do?
Box.
Oh, don't box that. We can reduce that, right? So it's not divisible by 2, but it is divisible by 5. 125 divided by 5 is 25, and 1,000 divided by 5 is 200. Okay, can I reduce that? Yeah, I can reduce by 5 again. 25 divided by 5 is 5, and 200 divided by 5 is 40. Can I reduce that? Sure can. Can reduce by 5 again. 5 divided by 5 is 1, and 40 divided by 5 is? Can I reduce that? No, I'm never going to be able to reduce something with a 1 in the numerator. So we are done with that one. Next one, we have a fraction that we want to change into a decimal. How do I change 5/11ths into a decimal? What do we do to change any fraction into a decimal? Divide? Divide what? 5 divided by 11. So to change this into a decimal, we're going to do 5 divided by 11. And that's going to give us what? 0.454545. I'm not sure how many your calculator does. Does it end on that 4 there?
Yeah.
What do you think is going to keep happening though? It's going to be 454545. It's going to just keep going forever. Now, this is a repeating decimal. There is a way to show that this repeats, but for our purposes, this problem says that we need to round to the nearest thousandth. Which number is in the thousandths place? It's going to be that second 4 there, right? So that's the thousandths place, which means that everything else goes away. We get rid of everything after what we're rounding to. But then we need to decide if this last one we keep, if that's actually closer to a 5 or if it needs to stay a 4. What do we need to do with this one?
Stay at 4.
It's going to stay at 4?
No, it's going to round.
It's going to round up, right? So that next number, the 5, that first one that we got rid of, is 5 or more. So the 4 needs to go up. So this is going to give us the rounded answer of 0.455. Next one, this is the percent increase or decrease, but not like what we've been doing the last few days. What we're trying to do here is find the final price of something after some changes. This video game here normally costs $39, but it's on sale for 30% off, and we're also going to have to pay tax. So how do we figure out the final price of this thing? All right, so this is the one where we start at 100% and we add and subtract the changes. So the first multiplier we get, we're going to do the sale, the 30% sale. So what are we going to do for that one? Subtract 30%, and that gives us 70%. These are all percent, so you should have percent symbols on there. But then I don't want to work with the percent. I want the decimal, so I need to change that to a decimal and get 0.7. We get that by dividing by 100, right? Okay, so this right here is the multiplier for the 30% discount. We could multiply any amount by 0.7, and it's going to tell us how much it is after a 30% discount. Now let's do the same thing for the tax. But for the tax, instead of subtracting, we're going to have to add. So we do 100 plus 9.1% gives us 109.1%. And as a decimal, that's going to be 1.091. All right? Now what? How do we find the final price of that video game? We're going to multiply a bunch of things together, right? So what do we start with? The $39. So we start with the original price of the video game, and then we're going to change it by multiplying by each of these multipliers. So multiplying by 0.7, that's going to give us the price after the discount. And then what do we need to do? Multiply by 1.091 to get the price after the tax is added in. All of that together gives us what? 0.78 what? 43. Okay. What kind of number is this? Is this a percent? What is it? It is a decimal, but what does the decimal represent here? Money, right? We're talking about money here. So when we're dealing with money, which decimal place do we want to use? Not the tenths, the hundredths. So when we're dealing with money, we need the tenths and the hundredths for the cents part of it. All right, so that means that we're going to round to the hundredths place and get rid of everything after that. And is that 8 that we keep, is that going to stay an 8 or is it really closer to a 9? It's going to stay an 8 because the number next to it, that 4 that we got rid of, is less than 5. So our final answer here, our final cost is going to be 29.78. Am I done?
No.
Need one more thing, right? Dollar sign. We're dealing with money, so show that it's money. So the video game that was $39, really almost $40, is now going to cost us about $30 after the 30% discount. All right, on the back of your opener, the first couple of problems are percent change. The first one is just like what you saw on the worksheet, where you just have the starting number and the ending number with the arrow between, showing how it's changing. So how do we find the percent change for something like that? All right, so first write down what it is that we're finding. So the percent change equals, which one's going to go first? We're going to subtract these, but which one goes first?
71.
Why the 71? It's the new number. So the 90 is the old number, and the 71 is the new number. If it helps you to put that stuff in the formula, I would recommend writing that down. All right, so we're going to do 71 minus 90. And then that just tells us how much it changed overall. If we do 71 minus 90, it tells us that it went down by 9 because we get negative 9 there. But then as a percent, we need to do a couple more things. What else do we need to do? Divide by 90, and then multiply by 100%. And when we do that, we're going to get what? Negative 21.11111. Okay, now what? Now what? All right, now we need to round. So it says in the directions here, round to the nearest tenth of a percent. Where's the tenths place? First one after the decimal. Okay, so we're going to round that one and get rid of all the rest of them, everything after that. Is this one going to stay the same, or is it closer to a 2? It stays the same because the number next to it is also a 1, which is less than 5. So our final answer then is going to be negative 21.1. What kind of number is this? Is this money?
Percent.
It's a percent, right? So it's negative 21.1%. All right, so it went from, well, that's not right, is it? That's right. So it went down by $19 when it started at 90. So if it started at 100, it would have gone down by $21.1, or whatever the units are here. So that's good. So it went down by negative 21.1%. The next problem is the exact same type of problem. It's just written out as a word problem. So we have a stock price that cost $32.14 per share last year, and this year it costs $38.85 per share, so the price went up, right? We want to know for every $100 that we have invested in this stock, how much money we're going to make. Or I should say how much money we made. So again, we're going to do percent change here. Which number is the new number? Because we're going to do new minus old. Yeah, so the 3885, that's the new number, and the 3214, that's the old number. So percent change equals what? 3885 minus 3214 divided by 3214. We were always dividing by the original amount, the starting amount, and then times 100. Make sure you're careful typing this into your calculator. And what do we get for this one? 20.87741. Okay. Is that our final answer?
No.
No. What kind of number is this? Is this money?
Yeah.
No, we're dealing with money in this problem, but our answer is a percent. So we need to round to the nearest tenth of a percent. So again, we're in the tenths place, which is this 8 here, and cross everything else off of that. Is that 8 going to stay the same, or is it really closer to a 9? It's really closer to a 9 because the number after it is, it's a 7. It's 5 or more. All right, so our final answer then is going to be 20.9, and we said this is a percent, right?
Yeah.
All right, is that it? Is that all I need? No, there's, yeah, we need one more thing. We want to show that this is a 20% increase, so we'll put a plus in front of it to show that it went up by 20.9%. So for every $100 that I had in this stock, I would have earned almost $21. All right, one more. If you are playing cards, so you got a deck of cards, but in your hand you have 5 cards, and 3 cards in your hand are red. What are the red suits in the deck of cards? Anybody ever play cards? So there's 2 red suits and there's 2 black suits.
King.
The red ones are the diamonds and the hearts. And the black ones? Spades and
Clovers.
clubs, yeah. Which are sometimes called clovers. Looks like a clover, a 3-leaf clover. Okay, so 3 out of the cards in our hand are red. We want to know what percentage that is. So how do I figure out what percentage that is? It's not a percent change problem. So what I'm going to use here is actually this formula we talked about yesterday that looks like this. So it's going to be the percent over 100, because percent means out of 100, equals the number. In this case, it's going to be the number of red cards over the total, which is the total number of cards. All right, so let's just fill in what we can here. Do we know the percent? No, that's actually what we're trying to find, right? So we don't know that yet. We know that 100. That's going to go in the bottom. And then on the other side, do we know the number? Number of red cards is 3, and the total is 5. All right, and then since we don't know the percent, I'll just call that P. Now I will say we could do this a different way, and I'll talk about the other way in a second. For this problem, it's going to be kind of easy to do it the other way, but this way works pretty well too. So to solve this, what do? cross multiply. So we do p times 5 and get 5p, and we do 3 times 100 and get 300, and we set those equal to each other. Then to get p by itself,
Divide by 5.
divide by 5. 5's cancel on the left, leaving p. And on the right side, 300 divided by 5 is 60. And it is a percent, so we get p equals 60%. So 60% of the cards we have in our hand are red. Now, did anybody do this one a different way?
I just put a different variable.
Okay. One thing you could do is, if you recognize that it just says 3 out of 5 here, 3 out of 5 can be written as a fraction. So we could, from the very beginning, rather than setting up this proportion here, for this particular problem, we could say, hey, that 3 out of 5 is a fraction. That's just 3 over 5. And then we change that 3 over 5 into a percent. So to change that to a percent, we would do 3 divided by 5, and then times 100%, and that gives us 60%. Gives us the same answer. Okay, now, a lot of the word problems we're going to do with percents won't work out this way, because sometimes we're going to be looking for the number of something or the total number of something, so this method wouldn't work then. But if we're just looking for the percent, we can usually write it as a fraction first and change it to a percent.